Okay, recording. Yeah, sorry. So Mr. Sharu, you asked something in the WhatsApp. Sorry, I'm just looking at my screen at the bottom. Is there something you're asking? Mr. Sharu, are you there? Oh, right. Okay, sorry, nothing. So message came late. Okay, never mind. Sorry, continue. Okay, so basically, you need to form the Kirchhoff voltage law on this side on the left hand side of the circuit. Maybe I try to see if I can try and write something. Just a minute. I can off my video. I stop my video first. Otherwise, the one my bandwidth consume a lot. I switch off my camera. Okay. Yeah. Okay. So I'll just keep my microphone on. Okay. So this one, let's try and solve it now. We try and solve together if we can. Okay. Provided the pen that one can work. It's called the ink square. Use this one. Oops, sorry. Screen. Okay, maybe y'all can see my screen. Sorry, a bit clumsy here. The pen. Wait, trying to get the pen working. Okay, so basically, right, I want to form a loop here. Okay, so let me try to see if I can get my pens up again. Okay, y'all can see my screen, I hope. Okay, so I want to form a loop here. My pen. Yeah. Say color. Okay, let's try. Okay, here we are. Okay. So what you want to do is in solving this problem or this question is to form the current loop here. All right. So okay, based on the solution that you have, you can see that what Mr. Chan did was he said that this current is called I3. Okay. So let me see. This pen is quite thick. Let's change it down a bit. Okay. So this part here is called the I3 current. Then of course you got the I2 current going this direction, I2. Okay, so and you have the I1 current flowing in this direction, right? So your I3, you can solve, you can sort of form an equation. Y'all can take notes. Y'all can take your own notes at your desk. So you can form the I3 current equals to your I1 plus I2. Do you agree? Okay.
Agree.
Can okay. So I1, I2. Now I think also what we can do is that we can form the KVL. Now I think to be honest, right, the key thing to tackle this type of question is to be able to form the equation correctly. If you can form the equation correctly, I think it's really like more than half the better one. Okay, so if you form this, first of all, you form this equation, the current one, because I can work out, I can use the KVL, if you recall, if you remember the Kirchhoff voltage law, KVL, right? Okay, let me reduce this thickness. It's too thick. Okay, yeah, okay. So your KVL would suggest to us that your V equals to IR. All right. So you need to form, let's say if I call this loop 1, if this is called loop 1, okay, then you can form a loop 2 here as well, right? This one. So you got another current loop going around this way. Okay, so you got loop 1 and loop 2. Okay, then you can form this KVL. So you can form by looking at the left-hand side loop 1 first. Let's say loop number 1. Correct. So your 12 volt, right, equals to your I1 R1, right? Okay, plus what? What is this part here? Okay, so you can see, let's say, okay, maybe I quickly flash out the solution. Sorry, I clear this screen first. Okay, so you can see what Mr. Chan did was that he formed this equation. Okay, so a bit difficult. I cannot show you the question and the thing together. My screen not as big as you understand. Not unlike in the classroom, I can show you the whole thing and then got a whiteboard to write. So I try my best here. Okay, so what he did was he formed the equation. Okay, with one of the branch first, with the 12 volt. You can see the 12 volt here is the voltage supply. Okay, so he formed 120, which is this 120 is the R1. If you notice, 120 ohm is the R1. Okay, so and then of course you got the 56 ohms times the I3. Okay, so go back to the question. Go back to the question. As you can see over here. Okay, then you have the I3. We call this the I3. This branch in the center branch here. Call it the I3. Oh, so okay, which is over here. All right. Then we also noted that you can combine. You can combine. There are different ways to doing it. Different ways. So what he did was he I1 because just now if you recall earlier your I3, right? Remember your I3 equals to your I1 plus I2. Yeah. So you can do it this way. Okay. You can form it this way. Okay. So then you form an equation A this one. Okay, to simplify. Yeah, so he used the I2 and I3. Okay, now I think some of you can try to do it your own way. If you want, you can try your own method. You should arrive pretty much at the same answer, so-called. So this part is you form A is the equation. Then he's saying here. Yeah, okay, so he formed the equation A. Then okay, then he looked at the second loop where he tried to form the equation B, so-called another set of equation, which is just now I say the loop, second loop, right? This one loop, the loop 2, right? So basically same thing. So but now you use the 10 volt supply. Okay, 10 volt supply. Okay, 10 volt equals to I2 times R3. Then I3 times R2. As you can see over here, that's what he did. Yeah, over here. Yeah, okay. So this is one of the way. So he used KVL and the KCL. Kirchhoff current law. Kirchhoff current law is the first one, this part here just now, which we show you. I1 equals to I2 plus I3. Okay, so this is that part. Yeah, then he solved after you form the equation A, equation B, right? Then you can just solve the current. So the rest is just simple mathematics only. I don't think there is anything, shouldn't be too unclear at this part. Can solve or not, this one? Hey, by the way, if those of you, I forgot to remind you one, so can you please kindly do your attendance poll for both the tutorial and the lecture, if you have not done so. Oh, thanks. Okay, so I think basically this part is to solve the current now, because once you find the current, the rest is easy already. Nothing much already. Once you find the current I1, I2, right? The rest is just to calculate the power, because we know power is quite straightforward, right? To calculate power, you use your okay, for power, right? Yeah, you can find the voltage drop, right? Individual voltage drop on each resistor. Okay, so you have the VR1, VR2, and your VR3. Okay, so you find that. Okay, and then you can calculate the power. Power equals to voltage times current. This one I think is quite clear cut. I hope. Yeah, because your power. Yeah. Okay, your power equals to I times V. Okay, so for this part here. Okay, so you can calculate the PR1, the power dissipated by the resistor R1. Okay, and then I think this one is the PR2. Okay, the power dissipation, same equation to use, same formula. This one here, okay, power to calculate, and then you can question ask you to calculate the total power, right, dissipation. So you can calculate. This one, I think, wait, let me see. This one should be PR3, if I'm not mistaken, or which is which? PR1. We can't got two PR1. Oh, so there's one of them is a mistake. You all know which one? Which one is the wrong one? Here, this one first. You have to look at your, okay, so basically, voltage or PR1, your voltage times the current, right? So you get V times I times V. Yeah, so this one is the VR1. This one. So this one, yeah, VR, this 7.27 volt. This one is your R1 resistor, right? Then just now you found the R2 resistor, is this one correct? 7 based on this voltage here, 4.73 volts. This is the voltage times the current. And then finally, this one should be a mistake. This one should be PR3. This one should be a mistake. Oh, you all agree now? This one should be 3. Kok Chang, correct? Kok Chang.
Yes, sir. It should be. Yeah.
Correct. This one.
The R3 is 220.
Correct. This one got error, right? Should be PR3 not PR1 because PR1 is already up there. Yeah. Okay, so should be more or less okay. Then
so what about the first line?
Which one?
Question A, answer.
Why?
Can you go on top? Scroll up.
Scroll up. Wait. Scroll up. Scroll up.
Just now we talked about I3 equals to I1 plus I2, right? The first line actually saying I1 equals to I2 plus I3. Is it I3 equals to I1 plus I2?
Yeah, correct. I3 equals to I1 plus I2. Sorry. What do you say again? Sorry, you repeat what you say.
Just now we go back to the circuit is I3 is I1 plus I2, right?
Yeah.
Here it becomes I3 equals to I1 minus I2 already.
Yeah, that one the negative sign. Because I look at the direction of the arrowhead of the R2. If you look at the R2, right, the voltage arrowhead is pointing up, means that the current is coming down. You understand what I'm saying? If you look at your diagram, right?
So is this just a different solution or is
No, you see this one right now. If you look at this screen here, you see these three arrow right at the bottom one. Actually, they should be Mr. Chan should have colored differently. Then it's easier to see. But you understand what I mean? This arrow below the R1, the arrow here is referring to the potential. Voltage potential. You know what I mean? Because your I1 is going clockwise, correct?
Yeah.
So the current is going this direction. So your potential is acting against it, right? So the potential arrow is pointing this direction is correct, correct? You agree?
Yeah.
Okay, then similarly for I2, your I2 current going anti-clockwise, all right, towards this direction, towards the left-hand side. So your potential also this at the bottom of that pointing to the right-hand side is correct, agree? Okay, then you have this one, the center one, the R2. R2, the potential is pointing up. So where do you think the direction of the current is flowing?
Down.
Yeah, correct. Downwards. So that one is I3.
So actually I3 equals to I1 plus I2 lah.
I3 equals to I1. I3 equals to I1 plus I2. Yeah, correct.
Then if we go back to the answer, is it answer is wrong?
I think that one maybe got tweaking error. This one, you are saying this one, right?
The first line. I1 equals to I2 plus I3, but we are saying I3 equals to I1 plus I2.
Yeah, correct. This one, I think he formed wrongly. Yeah, I think so. Can try lah. Actually, I use another method to do one. I don't use this method. For me, I use the KVL on I form. I don't even have I3. My method lah, which I did it on the video lah. That's why I did it. Remember last week I let you copy something on the Dropbox, right? Remember not? I given you all a link, right, to download some videos, right, from my Dropbox. Inside the video, I got explained. But the one I explained in class using the whiteboard. How I do it my way using the KVL.
Oh yeah, I remember.
You remember last week I gave one link, right? You all go and download, right? Inside the WhatsApp.
But I format my computer already. Can I have the link again?
The link, you formatted. You don't have the link.
Oh, I saw it. It's in the
chat. If you didn't clear your chat, then
it's inside.
The link is still there. Later you got time, you go and download.
Okay.
Okay. But if you end up, you will end up the same lah. You will arrive at the answer. Okay, go and try. Who is here? Wait now. Okay, then maybe if that one y'all go and try, go and try first, then you can look at the next question. I'll give you some time, y'all look at the question first. This one is a very typical question. Mr. Chan like to ask this one for his test. This one, and I think your as I mentioned, there will be a so-called end of semester test, right? This type of question will come out. Very common question. So I suggest, yeah, y'all try to attempt this question. So first of all, you have to study the data set that is given, right? So the question is quite clear. Yeah, they give you a voltmeter measurement, some interface, some measurement. Okay, and then they give you a set of readings. Sometimes the reading can be 10, can be 12. Okay, maybe can be like 15 or something. Okay, so now you have to make your observation in this. Now also partly you need to be familiarized with using your calculator. As you know, you need to calculate the readings, right? Like the mean value, standard deviation, okay, and then the median. All this can be done using your calculator. Okay, and then also in the polymorph, Mr. Chan got put in the video, right? How to calculate using the calculator. I think he did a small video on a YouTube or something to demonstrate the calculation part. So I think that one is quite important. You all should take some time to look at that video, how to do. Okay, so and then yeah, calculate, write down the outlier value. Can you any of you spot the value? Which one is the outlier? Outlier means is the value that is very far away from the general nominal value. You know what I mean? I think you all can spot, right? One of them is an outlier. This one, can you all spend some time first? Take a look first. Take a look at this question. You all done already? I haven't done. You all mostly haven't do. I think this question too. Anyone done already? Already finished? Quite quiet here. Okay, so this is the outlier, by the way. This is the outlier point. This one, if you notice, yeah, this value is way out from the standard value. Okay, that's why it's called outlier. This one, if you do not know, the word outlier means it's the one that is very far off. Okay, so if you look at this one, then this is the outlier. This one, so you have to pay attention. This is the outlier value. If the instrument set too fast reading the value, right? Now the outlier could happen because of many reasons. Things like fluctuation, maybe in your instrument, you are in the outdoor field environment. All right. Could be electromagnetic interference also, but not stated here. That actually can put here also electromagnetic interference, right? Humidity, maybe not so much, but there could possibly, but temperature and electromagnetic. is one of the cause for this instrument to may give you erroneous or erroneous value. That's all we call outlier. Okay, temperature especially. Temperature is genuinely a problem, especially in the outdoor environment. I think many of you know, right? You all work, sometimes you're out in the field. Those who work in those power substation, those kind of things, you all will understand. So this problem got fluctuation and so on. Okay, then if you are near to like maybe the power substation, right, the transformer, those large 22 kV, those type of transformer, step down, step up transformer, step down, a lot of magnetic interference also. Okay, so those could be genuine problem. All right. Okay, so then of course, yeah, y'all can calculate the mean calculation. This one y'all need to use calculator. If not, y'all do manually. Is quite tedious. Not doesn't make sense also. Okay, so you need to calculate manually. Now, why divide by 9? Can I ask somebody? Anyone can answer? Anybody knows why divide by 9? Mr. Kumar, you know, Mr. Kumar, you unmute yourself.
Total number of values, sir.
Why 9? Why not 10? Do you know?
The middle one, we take the total 9 numbers, sir.
Correct. The outlier lah, you saying? Is it?
Yeah.
Yeah, the outlier is not included.
Yeah, correct.
Correct. Okay, correct. You're right, Mr. Kumar. Thank you. Yeah, so basically you got 2, 4, 6, 8, 10 set of values, right? By right, but this value is outlier. So you for outlier case you cannot include. Why cannot include? If you include, what will happen? If you include, your value, mean value will be so-called disturbed. All right, you agree? Your mean value will be affected, so-called, if you decided to use the outlier, which people don't. So you take out, then you change, you divide by the average, it will be a different number. Total number will be different. So it will be 9. Okay, so your sample size has reduced to 9 instead of 10. Okay. Okay, now then you try to use the calculator to calculate the standard deviation. You have to try this one. I cannot show you here how to do your calculator. But anyway, my calculator is also different. Everybody got different. Genuinely, you mainly have different type of calculator, I think, and mostly for you guys. But my calculator is so different. I'm using the Casio FX 580, the dinosaur one. Your calculator maybe more newer. Okay, can be used, no problem. Okay. Hey, y'all know what is median value or not? Anybody not sure or not? You know what's median? I can show you. Okay, maybe just a small demo here. Okay, wait, let me bring down this block first. Okay. Okay, how to, okay, I'll bring my pen. Okay, can. Let's say, for example, I'll give you an example. Let's say you got a set of numbers. For example, okay, maybe I use a white screen. Okay, let's say, for example, I'm showing you a white screen. Okay, so let's say you got a set of numbers, right? Let's say 1, 3, 2, 6, 5, random basically I'm just showing you some random numbers. Okay, I think it's good enough already. Okay, in this set of numbers that you see, okay, 1, 3, 2, 6, 5, 3, and 9, right? Okay, if I ask you to calculate what is the mode, do you know what's mode? Do you know what's median? Okay, anybody want to try? What is mode? So what is the first thing you do? You got this type of data. Of course, if you got calculator, it's easy lah. You can key in this, right? But if I do by hand, what I need to do is, first of all, I arrange the number, right? From ascending order. So what I do is I would arrange in an ascending order. That means I start on the left-hand side with the smallest number. So I start with 1. Then I look at the next, from this data, what is the next smallest? 2, right? So I put 2. Then I look at the next one, the next smaller, 3. But I got another number 3 here, so I put 3 again. Then I continue. After 3 is what? 5, right? And followed by 6. And followed by 9. I put a comma for each number. Okay. So how do I know what is the mode? Equals to what? Anybody? What is the mode?
3.
Yeah, correct. Mode 3, correct. Thank you, Mr. Yo. 3 means is the most, the number that is the most occurring one. Okay, or the one that occurs the most frequent. Okay, correct. I hope you understand. Should be quite easy. The number that occurs the most frequent. So in this case, your number that keep appearing one is 3. Okay. Now what about median?
3, right?
3, yes, correct. How you get 3?
The median, they call median
Yeah,
number.
Yeah, correct. Basically, you are lucky because this case the number is the total number is an odd number. If you notice, so because you start from here, right? 1, 2, 3, 4, 5, 6, 7. There are 7 numbers, right? For this case, this is a set. Okay, set of numbers. Okay, is the number, okay, the number is an odd number, 7. So basically you pull out the middle one. This one. Okay, so this will be your median. What happens if your set of number is an even number? Then how? Okay, this one you take it, you pull this thing as a median because, right, is the median means the center number, right, out of this set. Right, this is the center because you got 3 here and then you got 3 numbers here, so it's fair, right? It's even, right? So there's 3 numbers on the left, 3 numbers on the right, so it's balanced, right? And this is the so-called the center number. You all understand? Yeah, this is the like the center number. Is it clear? This one? Can
Yes, clear.
Clear. This is the center number. That's why it's called the median. But what happens if your number is let's say for example, okay, I add one more number here, okay, in case you understand, trying to explain to you. Okay, I don't redraw everything. I just add one more number. Let's say another number here appears 12. Okay, so same thing, right? Just now the same set of number, I didn't do anything. I just add one more number only. So I put a 12 here. Okay, then so what is the new median? I call it median new. So what is it called? What is the median now? What do you do? Anyone? What should we do?
3 plus 5.
Very good. Thank you. You take this, now you consider this as well. Am I right?
Yes, correct.
Consider these two now. Because you must ensure that the numbers are on the right side and the number on the left side must balance. So there must be 3 numbers here and another 3 numbers here. So you will average out the 2 numbers in between. So what you do is that you take 3 plus 5 divided by 2. Right. So your new median, the new one will be 8 over 2 is 4. Do you agree?
Yes.
And this one quite fundamental. I think it's quite clear. Can? So should be quite okay. So very common mode, median, and the mean value. Also the mean is the average value lah. Okay, average value basically you just add them up, all the numbers, then you divide by the total number of the numbers in the data set. Oh, okay, can. This one quite easy. Then of course standard deviation, I think you use calculator. That one easier. Use the calculator to calculate. That one is more straightforward. Okay, so coming back to here. Okay, so you use calculator lah. This one. I let you all try yourself. This one, go and try. Okay, so no problem. I hope. Okay, then the 3 steps for this one, the instrument one. If you look at the question again, yeah. Okay, this one, yeah. This particular instrument, the RS232 instruction to be sent to the digital multimeter DMM using the following command. Explain the 3 steps. Okay, this one. I think you can look at this. Yeah. So basically, first thing first, you reset the instrument using this particular command called RST. Then you set the instrument to measure the DC voltage, right? Using this command DCV at range 1. Okay, for fast changing measurement. Then you might need to trigger, right? So you need to set the trigger, internal trigger. Then follow by to start the measurement. After you, these are initial one are all the setups. These are all the setting up to this point is to set up. Then follow by the trigger to measure. Then you start the measurement using this command trigger, right? And finally you store the value. Okay. Okay, can. Okay, this one. Okay, we go to the next question. Question number 3. Okay, this one. Okay, you read the question first. So you got 3. You got a waveform, a pulse waveform. All right, and you trying to measure this thing using 3 types of meters. Okay, so you got the 3 types. So you got the RMS one, you got the other type, mean rectified responding, and then the peak responding meter. So you are supposed to do this for individual type. You calculate all the 3, right? So if we look at the solution, let's take a look. Okay, so Mr. Chan actually did this one. Okay, so the calculation is quite simple. Period, I think we know. Period is 1 over the frequency, right? So 1 over the frequency. What's the frequency, by the way? Where's the frequency? Oh, okay, frequency is given, right? The frequency of the signal is given. So if you use your calculator, just try and calculate. 1 divided by 16.67, 60 hertz. 60 hertz. Yeah, 60. Oh, sorry, the period. The period. Wait, you are given the frequency. Sorry, you calculate the period. You're already given the frequency. Frequency is 16.67, right? So you 1 over inverse of the period. Oh, sorry, inverse of the frequency to give you the period of the signal. Okay. Okay, then you can do the rest. Okay, determine the period. Okay, name the waveform. Okay, determine the meter indication when it's DC coupled. Okay. When it's DC coupled, that means there's no AC signal. That means the signal is actually flat on the 0 volt. Okay, that's the meaning. You use the DC coupling. All right. So I think should be more or less there. Okay, now I think this one is the interesting part. I'm not sure you're familiar with your integration or not. This one is the key thing. Root, okay. The integration part, I think from my experience, many years over the years, students sometimes struggle with the maths. This one and the integration. This one, how to do the integration. This one. Okay, so that one is sometimes quite challenging. How to do the integration. This one. Okay, so maybe I can try to do one in the interest of time. Okay, I just do one just to show you. Okay. Now I think maybe for your ladies and gentlemen, you all must remember later, because I might need to start another Zoom session for the other group class to come in all together. So I don't think, unless because I'm recording this session, right? Because the recording will be very, very large. If I record plus together with the lecture. So what I thought was I would exit later on this session, because this is a tutorial, I will exit, because the issue is that the Zoom, after if I exit the meeting, they need to save the recording. Then they will need about 15 minutes to process. Then only I can start the next session. So I cannot end too late, because otherwise later the starting of the 8 o'clock one will be late. It will be delayed. Okay, so I will try to end in about maybe 10 minutes. 10 minutes time. Oh, okay. So maybe very quickly, let's take a look at this integration one. This one, unless you all say you all got no problem, then I don't need to go through this integration. Any problem or not? This one, how to integrate this thing? This one, do I need to go through the integration? 1 over t, that one in the integral, 0 to t over 3. This one, any question? This one, do I need to go through the integration? Quite long-winded. This one. You all know how to do integration, or?
I think we try one, sir.
Don't know, sir.
We try one.
know.
Yeah, don't know.
Don't know how to do. Okay, can. Then I try. I do for you. Okay, come on. We do one here. Okay, let me clear this screen first. Sorry. This one. Let's clear this mess. Okay. Okay, let's try quickly do one. Okay, so basically, right? Okay, let's try and do it one here. Okay, use the black pen. Okay, so we do one. So if I do the okay, if I try to do this, oops, sorry, my screen went offline. Okay, 1 over t, okay, integral, right? Okay, 0 to t over 3, right? And you integrate this center part. Square dt. Okay, when you do an integration, okay, so what you need to do is that anything that is constant, you can take out. Okay, but first of all, you need to, when you want to do integration, you remember the days when you all learn integration, let's say you integrate t, right? What do you get? If you integrate a t is 1, right? Remember the power is 1. So when you integrate t, what you do is that you take the power, you plus 1, right? Then divide by the total power, which is 1 plus 1, which is 2. So your integration of this is actually t squared over 2. Do you understand? Okay, this is the basic. This is the very basic. This one is maths. I tell you, this is nothing to do with engineering. This part here is mathematics. You integrate t, right? The t. What you do is that you put the t. Then of course you got the limits. In this case, I never put the limits. So it's t 1 plus 1 over 1 plus 1 is 2. So t squared over 2. You understand? So in order to integrate this one, okay, I might need to go a bit faster. So I put down this one first. Integrate 0 over t over 3. Right, so when I do the thing, I expand, I have to square first. because this is a square ma. So I need to do a 30 square. Okay, then you have the t square, right? Then you have the below the big T, this is the period, so it's t square. Okay, dt. Now notice I have not integrate yet. Okay, I just expand this power to the power of 2. Now anything that is constant can take out, as I mentioned. So what I do, I redraw this one, I put a 1 over t here. I can take out this, the denominator, the t square, okay, and bring it outside. Okay, because this one is t to the power 1, right? This one is t to the power 2. You can combine this power because the base is the same. So the index you can plus together become 3. You understand? 1 and 2 here, you can combine the power, become t cubed. So again, I don't integrate first. I put down this one, t over 3. Now 30, can I bring it outside or not? 30 square. Can I bring it outside? Can, right? Because this is a constant. So actually I can put the 30 square here. So maybe I put a small 30 square outside. Then now I left with only with the t square dt. This is the part I can do the integration. Okay, this part I can do the integration. So if I continue one more step, so anybody can help me what is 30 square? What is 30 square? 30 times 30. 900. Yeah, okay, very good. 900. So I'm going to put 900 here, and then I put t cubed at the bottom. Now then I'm going to start to do the integration. Now because here got limits, this is the numbers here are called limits. 0 then t over 3. This is called the limit. So what I need to do is I need to put a square bracket. Okay, put a square bracket for now. I'm going to integrate the t square. So I'm going to take t square plus 1, right? Remember I told you the integration rule then over here on the right hand side. Now you see this on the formula. So I'm going to take t square plus 1, right? Then divide by 2 plus 1. The same power. You divide. Then you close the bracket. Then you put the limits here. 0 t over 3. Okay. So this part, okay, I'm almost done already for the integration. Now, if I continue on this side, okay, so what I do is, what is 900 square root? Maybe let's get rid of that one first. So because there's a big, okay, never mind. Maybe the big outer square root, I keep it first. Okay, I just rewrite the whole thing. So I write it here. So I leave it as 900 over t cubed. Okay, now then I'm going to substitute the limits are inside the equation now into after the integral. This one I already integrated already. So I'm going to substitute this inside. So again, now the bottom part, the denominator 2 plus 1 is a 3, right? Okay, I can bring out. So I put a 3 here. Okay, I put a 3 here. Okay, so I left with t cubed, right? I never change anything. I didn't do anything. I just take 2 plus 1 is 3. I put it here. Then I put back the limits. Do you understand what I'm doing? I'm simplifying. I bring the 3 outside. Just now got one 3 at the bottom. I bring it outside here. Okay, and then finally, okay, I'm almost done already. I integrate. No, I mean I put this one. Actually, you can straight away divide it. If you do it fast, 900 divided by 3, you can straight away do the division or cancellation already. Then you substitute the limits inside now because this is t to the power cube. So I'm going to put this thing. I'm going to substitute the t with t over 3. So I'm going to put this thing inside. Okay, I just basically substituting here into here. Substitute here inside here. T over 3 cube. Okay, now 0 is anything is 0 now. Okay, so I think the rest I think you can solve. Okay, can solve. So this one is what? Not 100, right? No, sorry, 300. 900 divided by 3 is 300. So it's 300 over t cube, right? Then time this one is t cube, right? T cube. Then what is 3 to the power of 3? 27, right? 3 times 3 to the power of 3, 27 should be, right? So you will notice that, yeah, okay. So I will end up cancelling this top and numerator and denominator. They are saying I'll cancel away this one. So my final answer, of course, I got a square root here. Don't forget, I haven't run the square root. I haven't taken care. So my final answer is square root 300 over 27 with a square root there. Can you please check your answer? Okay, 300 divided by 27, then square root. Right, 3.33, right? Can you please check? Okay, quite a long-winded explanation.
Sir, is there anyone at the waiting room?
Huh? Oh, I don't know. I've been busily, I think so. Probably. Let me minimize. Okay. Somebody there. Oh, yeah. Okay, but I'm going to end soon, by the way, because I need to, as I say, I need to close the session to collate the video. Yeah. Okay, so here we are, there, 3.33, you understand? Okay, I can. Hey, I think maybe have to close the session already. Then, yeah, so you all try first, but I think it's quite a detailed explanation. Just now, if you follow through my explanation on my writing one, and it's also recorded. In case you're not sure, you can go back and refer. Oh, cannot. Can. So I think we stop here so that later on I close the session, the video can be converted properly. Then we will start. We will start at about 8 o'clock. I'll send you all another link.
Got it.
Okay, Ken, thank you. I will close and sign off here. Okay, y'all can go off. Thanks. I'll see y'all later. Later I'll send you all the link. Okay, thanks.